Good morning to all. In today's class, we will continue exception handling. Last class, I explained basics of exception handling. What is an exception and what is the purpose of exception handling and what is the meaning of exception handling. And we did some programs on exception handling. That is last class, we did some programs on exception handling. No? So all those programs come under customized exception handling. Now in today's class, I will explain what is default exception handling and what is customized exception handling and what is the difference between these two and who will do default exception handling and who will do customized exception handling. Okay, all these topics in depth we will discuss in today's class. Okay, now this is default exception handling. Another type of exception handling is customized exception handling. So we can say there are two types of exception handling techniques. They are default exception handling and customized exception handling. Now we will see what is the difference between these two. So when you take customized exception handling, already in the last class, we have written so many programs on customized exception handling. So what is the definition of customized exception handling is if the programmer is handling that particular exception which is raised in the program, whether it is arithmetic exception, null pointer exception, or array index out of bounds exception, class cast exception, string index out of bounds exception. These exceptions we did in the last class, no? Okay. So on these exceptions, we have written the programs in the last class. Now all those programs come under customized exception handling. Why? Because in all the previous programs, we have handled the exceptions. Means the programmer is handling the exception by including the try-catch blocks in the program. So writing the try-catch blocks is nothing but handling the exception. Okay. So in the try block, we will write the risky code, means exception code we will write in the try block, and we will write the matching catch block to handle that exception which is raised in the try block. So that is the meaning of try catch. If you write the try catch blocks in your program to handle the exception, that is nothing but customized exception handling. Okay, so how do we handle the exception programmatically is by including try and matching catch block. Okay, only simply writing the try catch blocks doesn't mean that handling the exception. Okay, suppose if arithmetic exception is raised in the try block, suppose if you write the catch block for null pointer exception, then what is the use? We have to write the matching catch block. So writing only try catch blocks does not mean that we are handling the exception. Okay, when we handle the exception is by writing the matching catch block for this exception which is raised in the try block. That is nothing but handling the exception. So if the programmer handles the exception, then that is customized exception handling. Okay. So what is the advantage of customized exception handling is graceful termination occurs. Graceful termination means, okay, after handling the exception in the catch block, okay, after the catch block also if you write any code, that will also be executed. Means the entire program is executed if you use try and matching catch block in the program. Okay, that is nothing but graceful termination. Okay, means graceful termination means the program is continuing normally. There is no abnormal termination. In between the program, we are not coming out of the program. Okay, so try block will be executed, matching catch block will be executed. After that, the code which is followed by this catch block will also be executed. Means the entire program is executed. Means that is nothing but graceful termination. If you handle the exception, okay, which is raised in the try block in the program itself, okay, then graceful termination occurs. So this is nothing but customized exception handling. Already we wrote so many programs on customized exception handling by taking arithmetic exception, null pointer exception, class cast exception, array index out of bounds exception, and this one, string index out of bounds exception. Okay, all those programs are under customized exception handling. Customized means programmer is handling the exception. Suppose if you write a program, okay, and we are now one exception is raised in that program, but we are not willing to handle that exception because the program is not interested to handle the exception. Means the programmer is not writing try catch blocks in the program, but exception is raised in the program. But I am not writing try catch blocks in that program. Then what will happen? That is the question. Okay, so that type of exception is nothing but default exception handling. So if the programmer is not handling the exception, then JVM will handle that exception. This is nothing but default exception handling. So it is done by JVM and customized exception handling is done by the programmer. That is the difference between default exception handling and customized exception handling. Suppose if you want to write the exception handling code, that is try catch blocks in the program, then who will handle that exception? Anyway, whether you write or not exception handling code, exception is raised because int a is equal to 10 by 0. 10 by 0 is an exception, no? But you are not handling that exception. Then in that case, JVM will handle that exception. If the programmer, okay, is not handling the exception, then who will handle that exception is JVM will handle that exception. Okay, if JVM will handle that exception, this concept is nothing but default exception handling. So using default exception handling, what will happen or what is the drawback of this default exception handling is abnormal termination occurs. Means whenever exception is raised from that statement, we will come out of that program. Means the rest of the program will not be continued normally. So that type of termination is nothing but abnormal termination. When JVM handles our exception, which is raised in the program, that is nothing but abnormal termination. What is the drawback of this abnormal termination is the rest of the program will not be continued normally. Okay, wherever you get that this exception, from that point we will come out of the program. Means the rest of the program followed by that exception or the remaining part of the program will not be executed normally. So this concept is called abnormal termination occurs. Okay, so with the default exception handling, abnormal termination occurs. With customized exception handling, graceful termination occurs. First try to understand what is the difference between abnormal termination and graceful termination. So with the default exception handling, abnormal termination occurs and JVM will handle the exception in case of default exception handling, and in customized exception handling, this graceful termination occurs and the programmer is handling the exception here. That is the difference. Now already we have written so many programs on customized exception handling till now. That is in the last class. We will revise once customized exception handling. So we have written program using arithmetic exception, null pointer exception, array index out of bounds exception, string index out of bounds exception, class cast exception. All these are predefined classes. See, in Java, exception is nothing but a class. So there are two types of exceptions in Java. They are user-defined exceptions and predefined exceptions. So all these are predefined exception classes. Okay, so here I have written predefined exception classes. Next, in today's class, I will also explain exception hierarchy, because all these are predefined classes now. Okay, so there are two types of exceptions in Java. Exception is nothing but runtime error, which is a class in Java. Because everything is with respect to classes only, we have to discuss Java, because Java is an object-oriented programming language. Okay. So here all these are predefined exception classes. So we have written one program on each of these 5 types of exceptions. So try to understand all these 5 programs, very, very easy only. And one more important point is all these programs are customized exception handling programs. See, last class I have explained this one. You see, customized exception handling. 5 programs we have written, one on each of those 5 types of exceptions. First one is arithmetic exception. We will revise once, after that we will go to default exception handling. So here class test, and I have taken main method. This is the syntax only, I will explain this. Class test, main method. Here inside the main method I have written system.out.println statement 1 in double quotes. Inside the main method I am writing try catch blocks. Why I am writing try catch blocks is here one statement is there with 10 by 0. Already you know 10 by 0 JVM cannot calculate because it is infinity, no? That's why it is runtime exception or runtime error. Runtime errors are nothing but exceptions in Java. If it is not a compile time error. Why? Because as per the syntax of Java language, this is perfectly correct. Why? Because it is a division operator which is taking 2 operands, 10 and 0 are called operands. So it is a binary operator. So as per syntax of this division operator, it is perfectly correct. That's why compiler will not give you any error with this 10 by 0. But when you execute the program, whenever JVM will execute this statement, okay, definitely it will give you runtime error. Why? Because 10 by 0 cannot be calculated by the JVM. Okay. So this is the reason why we are getting runtime error. So runtime error means it is nothing but an exception, no? So always try to write the risky code in the try block. This is my try block. That's why here I am writing the risky code which is 10 by 0. Next, see, before this runtime, this error 10 by 0, I can write any number of statements before this exception, and after this exception also I can write any number of statements in the try block. Okay, there is no problem. But when you execute the program, so this statement will be executed normally, and it will JVM will execute this try block. First it will execute this statement. After that, here it will get an error. It will find an error here in this statement. So from this statement, the JVM will come immediately from this try block, and it searches for the matching catch block. So what is this exception? JVM knows that it is an arithmetic exception. That's why it will come out of this try block from this statement, and it will execute the matching catch block. So this is the matching catch block for this exception. Now here you can find when it will come from this statement from the try block to catch block. See here so many statements if you write after this exception, no? So these statements will not get executed by JVM. Why? Because once it comes from this statement to catch block, again it will not go back to this same statement. It is not like return statement. Again, once it will come from this statement to this matching catch block, it never goes back to the same statement to execute the remaining part of that try block. That is the drawback here. That's why to overcome the drawback, don't write any statements after this exception statement in the try block, because this code will not be executed by JVM. Okay, before the exception you can write any number of statements, but after the exception in the try block, don't write any statements. If you write also no problem, syntactically it is correct only, but these statements will not be executed by JVM. That is the problem. Now it is called customized exception handling program. So what is the matching catch block? So this is the matching catch block, and this will be executed, and this will be executed. The entire catch block will be executed. After that, after catch block, if you write any number of statements, those also will get executed by JVM. This is the program on customized exception handling, and it is for arithmetic exception. Okay, so try to understand. If you follow the same syntax, you can write any number of exception handling programs, but you should know when we will get that particular type of exception. Means when you will get arithmetic exception, you should know. Like that, when you will get null pointer exception, when you will get array index out of bound exception, like that, at least for each exception, you should know one example. With that example, you can write the programs on your own, no need to by heart here. At least minimum 10 exception, customized exception handling programs, you should be able to write. Already we have written 5, What are the 5? Arithmetic exception, null point exception, and array index out of bounds exception, string index out of bounds exception, and class cast exception. All these programs I explained very clearly in the last class. So all those 5 programs are customized exception handling programs. So here I have revised once this, Okay. So with the same concept, write the remaining programs. Okay. So null point exception means if you take one reference variable, okay, and that reference variable is assigned with null, but it is not pointing to any object. But without that means the reference variable is not pointing to any object, because we have taken student S1 is equal to null. Student S1 is equal to null means S1 holds null, means it is not pointing to the student class object. Without doing that, what I am doing is, I am trying to access the student class members, that is roll number and marks, with S1. Means system.out.println S1.roll number and system.out.println S1.marks. So in this case, again it is a runtime error. Why? Because to access the members of that student class, the reference variable must point to that object. But the reference variable is holding null. That's why it is called null pointer exception. So you can explain null pointer exception program, that is customized exception handling program, either with string class, which is a predefined class, and or with student class, which is a user defined class. If you want to explain with the student class, first you should write student class. But if you want to explain with string class, you need not write string class, because it is a predefined class. It is there in your program. Why? Because for each and every program, the first statement is import java.lang.star. So inside the lang package, we have string class. That's why automatically that string class is imported to your program. That's why you need not write the string class, because it is a predefined class. For string class, code is written by the Java developers. Directly you can use string class. Again, take string s is equal to null and s dot length or s dot caret. Inside string class, we have so many methods. See, in your lab syllabus, you have string is there. Okay, try to practice number of methods which is available in the string class. Okay, in the lab, you have, I think, string and string buffer. Okay, you know, those programs are there in the lab syllabus now. So you try to practice. Now here, this is the program on arithmetic exception, which is customized exception handling program. Now here you may get one doubt. Suppose if you are not, okay, if you are not writing the code for exception handling using try catch block, then what will happen? Then this case comes into picture. If the programmer is not handling the exception, then the JVM will handle the exception. In this case, abnormal termination occurs. But here I will explain the procedure for default exception handling. Means how the JVM will handle that exception and which output you will get. So if you see the customized exception handling for arithmetic exception, what is the output? Because here we are handling the exception, the output is C, statement 1. Okay, and here in this program we will see statement 1 output I am explaining for customized exception handling. So statement 1, statement 2, and from this it will come to the catch block, and arithmetic exception is handled. Next 5, next statement 4. See, this is called graceful termination till the end of the main method. So the entire code is executed. Only which part is not getting executed is only the code which is there after the exception statement in the try block. Only this part will not be executed. Otherwise, the entire program is executed till the end of the main method. That's why in customized exception handling code, you will get the output as for this program: statement 1, statement 2, then arithmetic exception is handled, then 5, then statement 4. This is the output which we are getting after execution of this customized exception handling program. Now understand this one. Okay, now we will go to the default exception handling code and we will see what is the output in case of default exception handling. Okay, this is done by JVM and abnormal termination occurs. So in this case, we will see what will be the output and how the JVM will handle that exception if the programmer is not handling that exception. This is also very, very important in exception handling. We will go to default exception handling code. So this is the procedure for default exception handling. Try to understand, this is very, very important. Unless you understand the default exception handling, you can't understand the output, okay, for default exception handling programs. If you understand this procedure, then you can understand the output, okay, which is there for default exception handling programs. Okay, because the programmer need not handle the exception always. No, sometimes he may handle, sometimes he may not handle. Suppose if he is not handling, then JVM will handle that exception. You will get separate output in case of default exception handling because abnormal termination occurs in case of default exception handling. That's why if you understand the procedure for default exception handling, then you can understand the output which we are getting for default exception handling programs. I will show you one program. You can identify whether it is default exception handling program or customized exception handling program. Already explained customized exception handling program. No, 5 programs I explained. No. Now, if you see this program, first understand the difference between customized exception handling and this default exception handling. If you see this program, see, name of the class is exception demo 1 main method. Inside the main method, I have written 2 statements followed by 10 by 0. 10 by 0 is an error, no? Okay, it is an exception. But here, please check here. Here the programmer has not written try catch blocks. Simply he has written only statements. Means what does it mean? The programmer is not handling the exception which is raised in this program. Okay, he is not handling the exception which is raised in the program. Then when the programmer is not handling this exception, then somebody should handle, no? Okay, so in this case, who will handle this exception is JVM, and we will see how it will handle this exception and how it will give you the output for this program. So for this program, what is the output? First we will see statement 1, statement 2. Here exception is raised, no, in this statement. That's why immediately from this statement, it will come out of the main method. Out of the main method without executing the rest, this remaining statements. Means what will be the output for this program? Statement 1, statement 2, followed by, it will give you, it is an exception. That is the output for this program, because these 2 statements will not be executed by JVM. From this, it will come out of the main method. Means it is nothing but abnormal termination. So in default exception handling, we will get abnormal termination. Means the rest of the program will not be executed after this exception statement. That's why in this case, first we will see the output. If you understand the output, after that we will see the procedure for default exception handling. So what is the output? Abnormal termination occurs now. So statement 1, statement 2, no problem. See, after that exception is raised, no. So for that, the JVM is giving this as output. What is the output? Arithmetic exception, because 10/0 is arithmetic exception, no. So arithmetic exception colon this one slash, then this slash is nothing but divide by 0. What is the description of that exception is divide by 0. This is the name of the exception for 10/0, and the description of the exception is divide by 0, and it will give you the stack contents. I will explain what is stack trace. I will explain this part. So in case of abnormal termination, this is the output which is given by JVM. Now you should know how we are going to get this output and how the JVM is giving this as output in case of default exception handling. Because some procedure must be there, no? Without applying any procedure, how the JVM will give this as output in case of default exception handling? Okay, now how we are getting this output? We should know with the procedure of default exception handling. So now I think you can understand the difference between default exception handling and customized exception handling, and what is the output in case of default exception handling. This is the output, and what is the output in case of customized exception handling. Already we have written 5 programs on customized exception handling. You know very well how the output you are getting for those 5 programs. But here the how this output we are getting, no, for this default exception handling program, you don't know, no. Simply we are getting this output, but you don't know the reason. That's why I want to explain how we are getting this output in case of default exception handling. Now for that, we should understand what is default exception handling and what is the procedure for it. If you understand this procedure, then you can understand the output. Suppose if you go to interview, then they will execute that program, then you will get the output as arithmetic exception colon divide by 0 and stack trace. So how you are going to get that output? Please explain if somebody asks like that. So there should be answer with you, no? Okay, that's why you should know the default exception handling mechanism. This is very, very important. Now I will explain. This is simple only. So default exception handling mechanism in Java. If the programmer is not handling the exception using try-catch blocks, then this will come into picture. Okay, because we can write 2 types of programs. One is by handling the exception. Another one is if you don't want to handle that exception. So these 2 types of programs we can write with exception handling, but not with exceptional handling. With respect to exceptions, we can write 2 types of programs. The programmer can handle, or the programmer is not willing to handle. If the programmer is willing to handle, then no problem. It is well and good. You can see the output and you can understand the output also. But if the programmer is not willing to handle that exception, means somebody is handling that exception, no? That somebody is nothing but JVM, no? Then we should know the procedure, how the JVM is handling that exception and how it is giving that output. For that reason, you should understand this procedure. Okay, this is very, very important. Now we will see default exception handling procedure. See, if we won't handle the exception, then JVM will use the following procedure to give the output. Okay, means we are not writing try-catch blocks in the given program. That is nothing but we are not handling the exception. Then JVM will use the following procedure to give the output. Step 1. If the exception is raised in any method, then that method is responsible for creating exception object by including the following information. Okay, if an exception is raised in one method, okay, I will explain with example. First, understand the procedure. If an exception is raised in one method, then that method is responsible for creation of that exception object. Exception is nothing but a class, no? For that class, an object is created by that method. In which method exception is raised, that method is responsible for creation of exception object. Okay, object means some information will be there inside the object. Now, you know, student class, roll number and marks are there, no? Like that, for that exception, that method will create an object by including the following information. So this object contains name of the exception, means like arithmetic exception, null pointer exception, like that, and the description of the exception, like I have shown the output, no? Arithmetic exception colon divide by 0. That is nothing but a description of the exception, and the location of the exception means stack trace. Now I will explain the stack trace. So location of the exception also, it will save inside the object. Okay, again I am repeating, if an exception is raised in any method, then that method is responsible for creating the exception object by including the following information: name of the exception, description of the exception, and location of the exception. It is nothing but stack trace. Next, this is step 1. I will explain with example. Next, after creation of that exception class object, the method handovers that object to JVM. See, after creation of that exception class object, that method will hand over that exception object to JVM. Means this object is created by JVM. This object is created by that method, and that method is handovering this object to JVM. That is step 2. Next, what is step 3? So JVM will check for exception handling code in that method. Okay, so with this object, now object is with JVM. First method will create the object. After that, it will hand over to JVM. After that, with this object, okay, JVM will check for exception handling code in that method. If that method does not contain exception handling code, then JVM will terminate that method abnormally and removes the corresponding entry from the stack. Okay, again I am repeating. If the method does not contain exception handling code means try catch blocks. So if the method does not contain exception handling code, then JVM will terminate that method abnormally and removes the corresponding entry from the stack. I will explain this one. So with that object, JVM will go to that method and it will verify for exception handling code, whether in that method whether exception handling code is there or not. If it is there, it will execute that code, that exception handling code. If it is not there, then what the JVM will do is, JVM will terminate that method abnormally and removes the corresponding entry from the stack if the method does not contain exception handling code. This is step 3. With example, I will explain later. First, understand the procedure. Next, step 4. Next, JVM identifies because the JVM removes that method abnormally, no, from the stack, no. After that, what the JVM will do is, JVM identifies the calling method of that method. Calling method important. JVM identifies the calling method of that method and checks for exception handling code in the calling method. I will explain what is the difference between calling method and called method. So JVM identifies the calling method and checks for exception handling code in the calling method. If the calling method also does not contain exception handling code, then JVM terminates that calling method also abnormally and removes the corresponding entry from the stack. So first JVM will identify the calling method of that method, and if the calling method also does not contain exception handling code, then JVM terminates that calling method also abnormally and removes the corresponding entry from the stack. So JVM continues the same procedure till the main method is reached. Next, once the main method is reached, JVM will verifies exception handling code in the main method. Okay, so JVM continues the same procedure till the main method is reached. Once the main method is reached, JVM verifies exception handling code in that main method. If the main method also does not contain exception handling code, then JVM terminates the main method abnormally and removes the corresponding entry from the stack. Okay, this procedure I will explain with one or two programs. Don't worry, first try to understand the procedure. Easy only. Okay, So if the main method also does not contain exceptional handling code, then JVM terminates that main method also abnormally and removes the corresponding entry from the stack. Okay. Next, just before terminating the main method from the stack, understand this one, last point. So just before terminating the main method from the stack, JVM handovers that exception object to the default exception handler. Because first initially object is created by that method in which that exception is raised. Okay, that is the first statement. After creating that exception object, that method handovers it to JVM. After that, JVM will take that object, and with that object, first it will verify the exception handling in that method only. In that method, okay, if the programmer has not written exception handling code, then JVM terminates that method abnormally and removes the corresponding entry from the stack. After that, what the JVM will do is, with that object, JVM will go to the calling method of that method. Okay. Next, again, JVM will verify the exception handling code in the calling method of that method. So, in the calling method also, if the programmer has not written exception handling code, then what the JVM will do is, JVM will terminate that method also abnormally and removes the corresponding entry from the stack. So, okay. So, again, what the JVM will do is, with that object, again, JVM will go to the calling method of that second method. Okay, again, it will verify the exception handling code for in the calling method of that method. Again, assume that code, exception handling code is not there in the calling method of that second method also. In that case, again, the JVM will remove or terminates abnormally that method and removes the corresponding entry from the stack. Like that, the procedure is continued by the JVM till the main method is invoked. Once the main method is reached, what the JVM will do is, JVM will verify the exception handling code in the main method. Suppose if the main method is also, this is the last point, if the main method also does not contain exception handling code, then JVM terminates that main method abnormally and removes the corresponding entry from the stack. Next, last point, see. Just before terminating the main method from the stack, JVM handovers that exception object to default exception handler. But who is this one? Default exception handler. So last step. So default exception handler is a part of JVM which prints the object information on the console as output. See here we are how we are getting the output in case of default exception handling is this last sixth step is very, very important. So default exception handling. So who this JVM handovers that exception object to whom? To default exception handler. So finally, default exception handler is a part of JVM which is responsible for printing the object information on the console as output. So this is the procedure for default exception handling. Once you understand the procedure, we will apply the same procedure for default exception handling programs. Now I will explain that procedure with this program. Okay, try to understand each and every step is very, very, very important in that procedure. Without understanding default exception handling procedure, there is no use of studying exception handling programs. Blindly you are getting that output. But how you are getting that output, you should be able to explain. Otherwise, there is no use of studying this exception handling, because exception handling is very, very important when you go to interviews. Okay. Now default, we will write one program on default exception handling, and we will apply the same previous default exception handling procedure for this program and try to understand each and every step of that procedure by correlating with this program. Okay, now with this program you can understand more clearly. There is no doubt. You will not get any doubt. Now see, listen carefully, I will explain. So class exception demo. This is a program on default exception handling. If you see this program, see programmer has not written any try catch blocks. See, is there any try catch blocks? No. No means what? If you write the try catch blocks in your program, that is the program on customized exception handling. But here in this program, there is no, okay, no try block, no catch block, simply normal statements. Means is it a program on default exception handling? Yes. Now at least try to understand how to differentiate default exception handling programs and customized exception handling programs. Already we have written 5 programs in the last class. All those are customized exception handling programs. Why? Because in all those 5 programs we have written try catch blocks. But this program comes under default exception handling program. Why? Because here there is no try block, there is no catch block. See, but still exception is there. Means 10 by 0 I have written. So what will be the output? Already explained. You will get for this the output you will get like this. This one. This is the output. Whenever the JVM executes that statement, exception in thread main java.lang.arithmetic exception :divide by 0, and this is stack trace. I will explain stack now. This is the stack trace. This is the name of the exception. Okay, this is the description of the exception, and this is the stack trace. Means location of the exception. Okay, this is the output you are going to get if you execute the default exception handling program. But how you are getting this output? You should, if you understand the default exception handling procedure, then you should know this output. Otherwise, without understanding default exception handling procedure, you cannot understand this output. Blindly, if you execute that program, you are getting this output. That's it. Okay, but my focus is on how to explain this output with default exception handling procedure. Okay, now I will explain. Already explained the procedure. Now we will take this program, and with this program I will explain the procedure more clearly. Okay, now so exception demo is my class. Inside this main method, inside the main method I have one method, doStuff. Is it invocation of the doStuff method? Yes. Inside one method we can invoke only methods. We can't write the definition of this method inside this main method, because inside one method definition, this is the definition of main method. Inside one method definition you can't write one more method definition, but inside one method definition we can invoke any number of methods. This is method invocation. Here put semicolon. Okay. Now doStuff method invocation is this. So with respect to these two methods, okay, I can call main is calling method and this is called method. So who is calling this method? Main is calling. That's why main is called calling method. Here main is calling method and doStuff is called method. That is the difference between calling and called methods. Because in the procedure we have used calling method now. So when you take with respect to these two methods, main is calling method, doStuff is called method. Put semicolon here. Next we will see the flow. Now first JVM invokes the main method. Okay. When you execute the program, JVM invokes the main method first. After that it will find this statement. So this is only method invocation, no? That's why from this statement it will come from this statement and it will search for the matching method definition. So here it will find doStuff method definition. So from this statement it will come to this statement. So this is the definition of doStuff. So here I am invoking one more method, that is do more stuff. So with respect to these two methods, I can say doStuff is calling method and do more stuff is called method. Understand the difference between calling method and called method, very, very important. Next, so JVM will execute this one, no? doStuff. Again, it will find this statement. So do more stuff. Put semicolon. Is it the method invocation of do more stuff? Yes. There is no space here. Do more stuff. So from this again, it will come to this matching method. This is the matching method for this one. This is method invocation. This is method definition. Understand the difference between invocation and definition. Definition means body must be there. From this statement, it will come to this statement. Means this method definition. It will execute this one JVM. So it will go to this method and it will execute first hello. That's why in the output, if you see, first statement is hello. Okay. Next, after that, here I will explain the stack also. So see, whenever you see this program comes under single threaded programs. Next, in 4th unit, we will see multi-threaded programs. So what is the difference between single threaded program and multi-threaded program is, here there is only one thread and the name of the thread is main. Main is the only one thread in this program. Whatever programs we have written till now, all those programs are single threaded programs. Why? Because we have written only main method inside the class. That's why main is the single thread. Okay, main is the thread. If you write we can take any number of threads in one program. We will see those programs in the 4th unit. Okay. Next, one more important point is, for each thread, one new stack will be created in the memory. For each, again I am repeating the same statement. For each thread, one new stack will be created in the memory. Here I have explained, this is a single threaded program. Here only one thread and the name of the thread is main. That's why for this thread, one new stack is created in the memory. If you take multi-threaded programs, suppose if a program consists of 3 threads, then how many stacks will be created inside the memory? 3 stacks. One stack for each thread, remember. But here I will explain in multi-threading. Now try to understand stack concept. Here main is the only one thread. That's why only one stack is created in the memory. After that, okay. So main is pushed into the stack along with its local variables. Okay, main is pushed into the stack along with local variables. But inside main method, I have not written any variables. That's why only main method is pushed into the stack. After that, next from main method, we are invoking do stuff method. No? So at this point of time, do stuff method is invoked into the stack. Okay. Next, from do stuff method, we are invoking which method? From do stuff method, we are invoking do more stuff method. That's why do more stuff method is pushed into the stack. Okay, first main method is pushed into the stack. From the main method, do stuff method is invoked. That's why do stuff method is pushed into the stack. Next, from do stuff, we are invoking do more stuff. That's why do more stuff method is pushed into the stack. Like that, we will push the methods into the stack. Next. So do more stuff is pushed into the stack. No? Means do more stuff method is executed. So what will happen? Hello. First hello is printed as output. This is hello. After that, what is the statement? Now try to understand here. What is the next statement? System.out.println 10 by 0. It is when JVM finds this statement, it is finding an exception, means runtime error. Then in this case, what will happen is, here in this program, the programmer is not handling the exception. No? Whether the programmer handles the exception or not, the same procedure will be applied for each and every program. So here 10 by 0 is a runtime error. So here what is the here I am applying the default exception handling procedure. So this statement is getting executed normally, no doubt in this. When this statement is getting executed by JVM, we have to apply default exception handling procedure. Okay, so up to this, we have a stack like this, and main method is pushed do more stuff. These are the stack contents inside the stack. Okay, up to this statement. Next we will see. So whenever this statement is executed by JVM, first the default exception handling procedure is applied. So what is the default exception handling procedure? First step, when an exception is raised in any method, that method is responsible for creation of exception object by including the following information: name of the exception, description of the exception, and stack trace. Okay. So here 10 by 0 exception is raised in which method? two more stuff. That's why who is responsible to create the exception object for this exception? Do more stuff only. Understand? Now do more stuff is creating exception object. See, do more stuff is creating exception object like this. This is exception object. So name of the exception is 10 by 0 is arithmetic exception. Description of the exception is divide by 0. Okay. Next, what is the stack trace? This is stack trace. Now what is the stack trace? We have same stack trace from top to bottom. That is do more stuff, do stuff, main. Because why it is top to bottom is first which method is popped from the stack. Stack follows last in first out principle. No? That's why this is the last method which is pushed into the stack. That's why this is the first method to be popped from the stack, top to down. Okay. That's why first do more stuff is popped into the stack, then do stuff, then main method. That's why the stack trace is do more stuff, do stuff, and main method. So this is the object which is created by which method? Do more stuff. This is step 1 in the procedure. Okay, if an exception is raised in any method, then that method is responsible for creation of exception object by including the information, name of the exception, description of the exception, and stack trace. Up to this, okay, no? Next. So this exception object is created by do more stuff. After that, in the procedure, next do more stuff method handovers this exception object to JVM. Now do more stuff method handovers this object to JVM. Now this object is with JVM. This object is with here you can put JVM. So this object is with JVM. So with this object, what the JVM will do is now apply the steps of that procedure. So JVM with this object, JVM will go to the same method. Which method handovers that object to JVM? Do more stuff, no? That's why with that object, JVM will enter into the same method and verifies whether exception handling code is written by the programmer or not. Here there is no exception handling code, no? So in that case, the JVM terminates this method. JVM terminates this method abnormally. JVM terminates the do more stuff method abnormally and removes the corresponding entry from the stack. That is step 2. Removes the corresponding entry from the stack means it will remove do more stuff from the stack. Now the stack contents are main and do stuff. Okay. Now it terminates this method abnormally and removes the corresponding entry from the stack. Okay. After that, with that object, what the JVM will do is JVM will identify the calling method of this method. Who is calling do more stuff? Already explained the difference between calling and called methods. So who is calling this method is do stuff is calling do more stuff method. So with that object, JVM will identify the calling method of do more stuff, which is this one. So JVM will go to that method. Okay, the calling method of do more stuff is do stuff. That's why with this is terminated now by JVM. After termination of this code, this method, with that object, JVM will go to the calling method of that method, that is do stuff method. Again, it will verify inside the do stuff method whether exception handling code is written by the programmer or not. Here also it will not find try catch block, no, means no exception handling code. In that case, what the JVM will do is again the JVM will terminate this do stuff method also abnormally and removes the corresponding entry from the stack. Now after removing do stuff from the stack content is main method only. Next, after that, what it will do, again same procedure. Next, again the JVM after terminating this method by JVM will identify the calling method of do stuff method. Who is calling do stuff method? Main method is calling, no? That's why JVM identifies the calling method of do stuff, which is main method, and it will enter into the main method. Again, inside the main method, it will again check whether exception handling code is written by the programmer or not. Here, no exception handling code means no try catch blocks. So in this case, what the JVM will do is, so repeat the same procedure until the main method is reached. Already it reached the main method. So here what it will do? As per the procedure, JVM continues the procedure till the main method is reached. Once the main method is reached, JVM verifies exception handling in that main method. If the main method also does not contain exception handling code, then JVM terminates the main method abnormally and removes the corresponding entry from the stack. We will follow that one. So JVM will not find exception handling code in this method. So JVM terminates this main method abnormally and removes the corresponding entry from the stack. But just before, now see, but just before terminating the main method from the stack, JVM handovers, because till now the object is with JVM only, no? But just before terminating the main method from the stack, JVM handovers that exception object to default exception handler. Okay, now just before terminating or just before removing the main method from the stack, JVM handovers, till now this object is with JVM only, no? So just before terminating that or just before removing that main method from the stack, JVM handovers this object to whom? To default exception handler. Okay, now we are in the last step of the procedure. So default exception handler is a part of JVM which prints the object information on the console as output. Now this object is with what? With whom? Default exception handler. So default exception handler is responsible to print the object information on the console as output. That's why we are getting this output. So this is the output which is given by the default exception handler. Who is created this object actually? Do more stuff is created this object. After that, do more stuff handovers that main method. Then not main method, JVM. Okay, first this object is created by do more stuff. After that, it handovers this object to JVM. With this object, JVM will check the exception handling code first in do more stuff method only. If it is not having, then it will go to the calling method of this method. Okay, again it will check in that exception handling code in the calling method of do more stuff, that is do stuff. In the do stuff also exception handling code is not there. And again it will JVM with that object, JVM will go to the main method which is the calling method of do stuff. In the main method also exception handling code is not there. Then in that case, JVM with this, till now the object is with JVM only, no? Now the object is, JVM handovers that object to default exception handler just before terminating the main method. So then now this object is with the default exception handler which is responsible to print the object information on the console as output. That's why, see, first statement is what? This is the hello. Hello executed. When it is this statement is getting executed by JVM, what will be the output? By using that default exception handling procedure, you will get this output. This is nothing but the object information which is created by do more stuff. So what is the object information? First, name of the exception. No? Name of the exception is arithmetic exception. If you write null pointer exception program for default exception handling code, you will get a different output. But here name of the exception is must for all the default exception handling programs. But divide by 0, this description is optional. For all the exceptions, you won't get description. Then in that case only name of the exception and stack trace. Okay. Now I will explain this output. That is the object information is the output. Okay. Default exception handler is printing this object information on the console. So what is the object information? And name of the exception. So name of the exception is actual arithmetic exception, but you have to write fully qualified name. Already in packages I explained fully qualified name. So what is the fully qualified name of this? Means this class is there in which package. Along with the package name, we should write the class name. That is nothing but fully qualified name. You know, inside java.lang package, arithmetic exception class is there. Okay, that's why what is the fully qualified name for arithmetic exception name? Arithmetic exception is java.lang.arithmetic exception. Okay, this is fully qualified name for arithmetic exception. Along with the package name, I am giving the class name. So java.lang. Arithmetic exception. Okay. After that, why it is giving like this is already explained. When you write multi-threaded programs, in any thread exception may be raised. No. Here we are writing single threaded only, single thread programs only. Main is the only one thread. But when you go to multi-threaded programs, inside any thread you may get exception. No? That's why along with the exception class name, in which thread that exception is raised. That's why along with the exception name, it will give you the thread name also. Because we will take the thread names as thread 1, thread 2, thread 4, 3, thread 4 like that. Inside thread 3, exception is raised means it will give you the thread name as thread 3 followed by the name of the exception. That's why along the thread name, it will give you the exception name. That's why here only single threaded and our thread name is main only, no? That's why exception in thread main. This is the name of exception in thread main means this is the name of the thread and this is the fully qualified exception name. And this is the this line is for name of the exception. Okay, name of the exception. Next column. If description is there, it will give you. Otherwise, it will not give you. So, what is the description for arithmetic exception is divide by 0. So, name of the exception and the description. Last one is stack trace. Stack trace means when it encounters this statement, what is the stack content? What are the stack contents from this point? Or at this point, what is the stack trace? First main method is pushed. Main method is pushed into the stack. From main method, we are invoking do stuff. That's why do stuff is pushed into the stack. Next, from do stuff, we are invoking do more stuff. That's why do more stuff is pushed into the stack. Next, we are coming to do more stuff definition. Means at this point, the stack trace is like this. Do more stuff, do stuff, and main method. That's why stack trace means it will give you the last part in the object is stack trace. No, so this is the stack trace. What is that? Yet test dot do more stuff. Do more stuff method is there in which class? Test class only. No, so along with the class name, this method is there because method must be there in one class. No, that's why without class name there is no sanctity for this method. That's why along with this method name, class name will be there. That's why test dot do more stuff, and inside this is do more stuff is a method now. Inside that it is giving one parameter, that is name of the file, that is test.java colon. This is line number of that method. So do more stuff method line number shall we see? Do more stuff line is 11. That's why along with the line number. Yeah, I already explained. Stack content means top to bottom only it will produce, because first this will be popped, then this will be popped, then this will pop. That's why it will give you the top to bottom order of the stack. That's why yet test dot do more stuff of test.java colon line number. Next, after that, what is the next this one stack content? Yet test dot do stuff of test.java colon 7 line number 7 for do stuff. Next, yet test dot main. Last method is main method now to be popped from the stack. That's why yet test dot main test.java column 3. So these three lines are nothing but stack trace. So name of the exception, description of the exception, and stack trace. So this is the output. In the lab, you do this program. Then you will get this output. How we are getting this output is using which procedure? Default exception handling procedure. That's why with that program, try to understand this procedure. Okay, so with this default exception handling procedure is completed, and I have given one more program also. So you try to understand. Now you understood this, no? You try to understand this program also. See here where I have written 10 by 0 in do stuff method. Now you can easily correlate this program with that procedure. Then you will get first main method, then do stuff. No? From this do stuff, it will go to do stuff method. See, from this statement only, it will not go to this one. From this statement, it will go to do stuff method, and from do stuff method definition, it will invoke do more stuff. So it will go to do more stuff, and it will print first hello. So hello is printed. Stack trace, see, same stack trace. Main method, do stuff, do more stuff. Next, once it completes its execution, that is do more stuff method is popped into the stack. Now the stack contents are main and do stuff after this method's execution. After that, again it will go back. After execution of this one, again it will go to the same statement. No, so do more stuff means this is also completed. Means do stuff also completes its execution. Means inside from the stack, do stuff is also popped from the stack. Only main method is there in that stack. Okay. Next, from this statement, it will go to the same statement. Okay. So this statement is completed. After that, this is the statement we have. That's why it is error again. Now in this case, which method is responsible for creation of exception object? Main method, no? Now main method is creating the exception object with the information same. With the same information, same object is created with this information. But who is creating in that program? Main method is creating that this object. In the first program, do more stuff is creating that this object now. But in the second program, main method is responsible for creating this object, and it is creating this object by including name of the exception, this description of the exception, and stack trace. If you see the stack trace, already do more stuff is popped from the stack, do stuff is also popped from the stack when that statement 10/0 is getting executed. That's why stack trace is only one statement, that is main method. That's it. But who is creating this object? Main method with the name of the exception, description, and stack trace is only main method. Because by reaching to that statement, already do more stuff is popped and do stuff is also popped. Only main method is there in the stack. That's why here main method is creating the object for arithmetic exception. And actually, if any other method is creating this object, that method is handovering that object to main. No? But here in this program, main method is creating means the object is with the main method. Here main method is creating the object and main method handovers that object to JVM. JVM, that is important. In the previous program, do more stuff method is creating the object and it handovers that object to JVM. No? Here in the same way, here main method is creating the object for this exception and handovers to JVM. Main method is handovering this object to JVM. So with this object, first JVM will come to this main method and verifies exception handling code. It is not there. But it has to reach the main method, no JVM. But here main method is the last method, no? That's why already it reached to main method. So that now when exception handling code is not there in the main method, the JVM they removes this main method from the stack and handovers this object to default exception handler. So default exception handler is responsible for printing the object information on the console. That is the output is, now you can see this output. So hello is printed, no? There is no problem in do more stuff, and also there is no problem in do stuff. Here problem is in the main method. That's why main method is responsible for creation of exception object and handovering to JVM. Okay, now JVM handovers that object to default exception handler, which is responsible for printing the object information on the console at the output. Now the hello, this is the information or the output which is printed by the default exception handler. Already explained what is the object information, name of the exception, description, and stack trace. Only in the last main method it is getting the 10/0 exception. No, that's why stack trace means only one line. Because main method is the last method to be popped from the stack. That's why only one line. Remaining everything is same. Exception in thread main java.lang arithmetic exception colon description divide by 0. And this is the stack trace because in the main method exception is raised and object is created. Okay, by that time this do more stuff is popped from the stack and do stuff is also popped from the stack. But still main method is there in the stack. That's why stack trace means this is the only one line you will get. Okay, so these two programs are on default exception handling. If you want to write the same program inside this do stuff also, you can put to this one. That is third program you try to write. In the first program, put 10 by 0 in do more stuff. In the second program, put 10 by 0 in do stuff. Okay. Then you will get stack trace as do stuff and main. Okay. This is third program. 3 ways you can write the same program. You will get 3 different types of outputs for stack trace. So you can put the same line instead of writing here, you write here. Means inside do stuff method, you write the system.out.println 10 by 0. Then see the output. So with these 3 programs, you can understand the default exception handling procedure perfectly. Okay. So try to understand default exception handling procedure.